Good morning, everyone. Thank you for joining me today. My name is Eddie Chong, and I will present the application of calculus in economic and geometry. We will explore how derivatives are used in various economic functions, delve into the Washer method for calculating volume, and understand moments and the center of mass. To begin, let us outline what we will cover today. Calculus is a powerful tool that finds application in numerous fields, including economics and geometry. Our discussion will be divided into the three main parts. First one is application of derivative in economics. We will examine how derivatives help analyze and optimize cost, revenue, and profit function. Second is Washer method for volume calculation. We will learn how to calculate the volume of complex solids of revolution using the Washer method. Third one is moment and center of mass. We will explore how moments are used to determine the center of mass of various objects. Understanding this concept will provide valuable insight into both economic decision making and geometric analysis. Let's dive into the first section, applications of derivative to economics. Derivatives are essential in analyzing how economic functions change with respect to different variables. The key economic functions we will discuss included cost functions, average cost functions, revenue functions, average revenue functions, profit function, average profit function. By understanding the derivative of these functions, business can optimize their operations, pricing, and profitability. Starting with cost functions, a cost function denoted as CQ represents the total cost of producing Q unit of a good or service. The definition of this cost function is total cost for producing Q unit. The derivative of the cost function with the respect to quantity C palm Qs is not and the marginal cost indicate the additional cost of producing one more unit. Example, if CQ equal to 50 plus 20Q plus 5Q squared, then the marginal cost is MCQ equal to uh, derivative of the CQ. So the equal to 20 plus 10Q. This shows that the marginal cost increase as production increase. Next, we have average cost function. The average cost function, ACQ, represents the cost per unit of output and is calculated as ACQ equal to CQ divided by Q. By taking the derivative of ACQ, business can determine the output level that minimizes the average cost, which is crucial for efficient production planning. Using the same cost function, CQ equal to 15 plus 20Q plus 5Q squared, ACQ equal to 50 plus 20Q plus 5Q squared divided by Q. So we calculate N equal to 50 divided by Q plus 20 plus 5Q. To minimize ACQ, set its derivative to 0. AC times Q is equal to 0. So 50 divided by Q squared plus 5 is equal to 0. And Q equal to square root 50 divided by 5. And we calculate then will equal to square root by tens. And we change it to determine number and become 3.16. Thus, producing approximately 3.16 unit minimize the average cost. We were moving on to revenue function. The revenue functions RQ represent the total revenue earned from selling Q unit and is typically expressed as RQ equal to PQ times Q, where PQ is the price per unit. The derivative of the revenue function R palm Qs is not an marginal revenue. It shows the additional revenue from selling one more unit. Example, if RQ equal to 100Q minus 5Q squared, MRQ will equal to the derivative of RQ, so it will equal to 100 minus 10Q. This indicates that marginal revenue decrease as the quantity sold increase. Next, we examine average revenue functions. The average revenue function, ARQ, is the revenue per unit sold and it's calculated as ARQ equal to RQ divided by Q. Analyzing ARQ helps firms determine optimized pricing strategy to maximize revenue. Example, using RQ equal to 100Q minus 5Q square, ARQ will equal to 100Q minus 5Q square divided by Q. So they will equal to 100 minus 5Q. This linear relationship shows that average revenue decreases as more units are sold, suggesting a downward sloping demand curve. Now, let us discuss profit function. The profit function, second Q, represents the total profit from selling Q units and is calculated as second Q equal to RQ minus CQ. The derivative of the profit function, second pump Q, is equal to MRQ minus MCQ, help determine the quantity that maximize profit. Example, given RQ equal to 100Q minus 5Q square and CQ equal to minus 50 plus 20Q plus 5Q square, the second Q will be equal to 100Q minus 5Q square minus 50 plus 20Q plus 5Q square, and so that will equal to 80Q minus 10Q square minus 50. So we're taking the derivative, the second pump Q is equal to 80 minus 20Q. Next, we will setting the second pump Q equal to 0, given Q equal to 4. So the answer will producing 4 unit maximize profit. Finally, within the derivative in economics, we have average profit function. The average profit function, APQ, is the profit per unit and is calculated as APQ equal to second Q divided by Q. Analyzing APQ allows firm to assess profitability on a per unit basis, guiding decision on scaling production. Example, using second Q equal 80Q minus 10Q square minus 50. APQ equal to 80 square minus 10Q square minus 50 divided by Q, and will equal to 80 minus 10Q minus 50 divided by Q. Analyzing APQ help determine the most profitable scale of operation. To summarize the key applications of derivative in economics, we focus on three main areas. First one is maximizing profit. By setting second pump Q equal to 0, business can find the optimal quantity Q that maximize profit. The second part is minimizing average cost. Setting AC pump Q equal to 0 help determine the efficient production level where average costs are minimized. The third part is demand analyze real average revenue. Utilizing ARQ allows firm to understand how pricing strategy impacts revenue and aligns with market demand. These applications are fundamental for effective economic decision making and operation efficiency. Shifting gear to geometry, our next topic is the washer method for volume calculation. The washer method is a technique in calculus used to find the volume of a solid obtained by rotating a region around an axis, especially when there is a hollow center. Washer. Imagine a flat ring shape with an outer radius upper Rx and an inner radius lower Rx. Volume formula. When rotating around the x-axis, the volume V is calculated as V equal to pi times the integer from A to the B upper Rx square minus lower Rx square dx. Here, AB is the interval of rotation. Let us look at an example of the washer method in action. The question is, find the volume of the solid obtained by rotating the region bounded by y equal to square root of x, y equal to x, and x equal to 0 about the x-axis. The solution set has four parts. The first step is identify the bounds. The curve y equal to the square root of x and y equal to x intersects at x equal to 0 and x equal to 1. The second step is determine the radius. The outer radius, upper Rx, is equal to square root of x. The inner radius, lower Rx is equal to x. The third step is step up the integer v equal to times the integer from 0 to 1, the square root of x times square minus the x squared dx. And we can write into the pi times the integer 0 from 0 to 1, x minus x squared dx. The last step is evaluate the integer v equal the times the quantity x squared divided by 2 minus x cubed divided by 3, evaluate from 0 to 1 equal to times 1 over 2 minus 1 over 3 is equal to pi over 6. The answer is the volume of the solid of revolution is pi over 6 cubic unit. Now let us explore moment and center of mass. These concepts are pivotal in physics and engineering for understanding the balance and disruption of mass within objects. A moment measures the tendency of a force to cause an object to rotate about an axis. In calculus, moments are used to find properties like the center of mass. The moment about the x-axis mx is equal to the integer from a to the b 1 times dA. The moment about the y-axis my is equal to the integer from a to the b x times the derivative a. The center of the mass is the point where the mass of a body is concentrated. For uniform density, it can be found using x bar equal to my divided by a, and the y bar is equal to the mx divided by a, where a is a total area. Let us solidify our understanding with an example of center of mass calculation. The question is, find the center of mass of the region bound by y equal to x squared and y equal to 0 between x equal to 0 and x equal to 1. There are three steps of this solution step. The first step is compute area A. A equal to the integer from 0 to 1 x squared dx and equal to in quantity x cubed divided by 3. You evaluate from 0 to 1, so the answer will equal to 1 over 3. The second step is calculate moments. Moments about the y-axis my. My is equal to the integer from 0 to 1 x times the x squared dx. And we can write into the integer from 0 to 1 x cubed dx and calculate. The answer will be the 1 over 4. And the moment about the x-axis mx is equal to the integer from 0 to 1 over 2 times the x squared times square dx. And we can write into the 1 over 2 times the integer from 0 to 1 x4 dx. And we calculate, the answer will be the 1 over 10. And the last step is determine the center of mass coordinate. S bar is equal to my divided by a. So will equal to 1 over 4 divided by 1 over 3. And answer will be over 3 over 4. And y bar will be mx divided by a. And we can write into 1 over 10 divided by 1 over 3. The answer will be over 3 over 10. The, the center of the map of region is at 3 over 4 and 3 over 10. In conclusion, we have explored how calculus, particularly derivative, plays a vital role in both economic and geometry. Derivative in economics, they enable business to optimize production and pricing strategy by maximizing profit and minimizing costs. The Washer method, this technique allows us to calculate the volume of complex solids of revolution, which is essential in various engineering and articular applications. Moments and center of mass. Understanding this concept help in determining balance point and mass disruption in physics and geometric objects. This application demonstrates the profound impact calculus has on real-world problem solving and decision making. Thank you.